Alright, so over here you have the histogram of the current employee plan, you have the frequency, and you have the plan. So, where am I? Okay. So over here you see kind of just like what's going on here. That's because there's one employee plan that just trumps everything else that's in here. So we're going to try finding that out. So which df 1.5 PQ current employee plan. I don't know, I'm going to assume not. There isn't much that offer over 10,000. Oh wow, there actually is some that's a lot greater than 10,000. But 20,000? Well, you got one that's like 350,000, so not many, I bet, are over 100,000. 200,000? Yeah, like see how these these represent the index numbers. So this like row 4,105 has an employee plan that's greater than 100,000. And because it's so few in number, it's barely registering on this scale. But when you're doing a histogram, all the data is concentrated in this portion. So we can fix that by getting rid of them. Again, because this is... Let's get rid of this just for fun. If it's over... Because only 67, 68, 69, 70, 71, 71 have a current employee plan that's greater than 20,000. I'm not doing this in the data set, but I just want to like show you like what happens if you get rid how your distribution looks if you get rid of these like giant ones. So we can go down here. Telling it negative means remove these columns, and then bracket means again negative which columns are greater than 20,000. Remove these columns, comma all the remove all of these rows, comma all the columns and you denote that by putting nothing in there. And then you want to do it on the data frame 1.5, and we'll call this like df 1.6. Now if we do df 1.6 current employee plan histogram, it should look a lot nicer. A lot nicer, but still not there. Let's get rid of everything from like 15,000 on. Or 10,000, no. Okay. So for the most part, you see a very decreasing current employee plan, which makes sense because most of the industries out there are sole proprietorships, and there's very few like super big industries. And after like a couple, like 10 or not a lot of industries have a lot of employees. Okay, actually, let me take that back. There aren't that big of a companies that hire a lot of industries, and as you go further out, the less you see in there, and that's why you have this decreasing curve. All right. Anyway, let's remove df 1.6 so we don't get confused. And so if you want to make that normal, what you can do is try logging. Oh shoot. Let's try that. And we could try logging it. Just want to see the distribution of it if you log it. Okay, that's interesting. Yeah, you could definitely normalize this by logging it. So that's something to consider. Anyway, going back to your summary df 1.5. Scroll up, just investigate different links. For example, like the growth score, profitability score, risk score, and play around with it. See if you can normalize your data, because that would actually help a lot when you're doing linear regression. And let's see. So over here, I was checking the website, and then I noticed like these repeated ones. And personally, for me, I found it a problem, so I wanted to get rid of it. Again, when I originally wrote the script, I did not account for companies with different divisions but having the same name, or just having two different names but having the same website. And I also noticed that within the websites, there's some websites that have NANA in it, and which I didn't catch the first time, but it doesn't really pose that much of a big deal. So first things first, we're going to turn it all into characters so that we could change it. Oh yeah, library string R. The reason why I keep doing library is because I didn't turn on all the libraries earlier. So what this does, it allows us to use the string detect command, which detects if there's any, which detects if there's any strings with NA, nana, within the characters that we give it. So in this case, we have false, NAs, and whatnot. So let's check it out. Let's sum all the ones that are true. So this shows that within our column of BQ website, 2,262 NA have been found. Let's see how many of them are attributed to HTTP nana. 2,252. So there's 10 of them that have NA but not HTTP NA. I'll have to look into those, but until further notice, let's deal with these. So what I did was I created a for loop to go for each single cell, and if it sees an HTTP NA, just get rid of it and replace it with HTTP. I also realized you could do the same exact thing with this line of code over here. This tells it to go to df 1.5 BQ website and to string replace everything from this to this. Now you can do the same thing in Excel, but that was just for fun. Now let's take a look at the last 10A. And funny enough, those ones were HTTPS colon NANA, and you can do the same thing. Literally. It seems because I did for loop for 10 of them. I didn't realize I could do this. HTTPS NANA. And if we go, let's see, there should be nothing in there. Yep, sir. So that's fixed. Now for the duplicated company sites. As we saw, summary, df 1.5, scroll up, website, okay. Well, we can't really see it here because it was changed to character, but let's change it back. df 1.5, BQ, website gets as.factor of it, and then website. Turn it into factor, and you store the new thing in the same column position. Cool. Now if we run a summary, scroll up, or rather, summary df 1.5. EQ underscore website. And it lists you like all the ones that are repeated. Or, well, it lists you everything. So there's 6 of them from First United Bank, 3 of them from Performance Trust, and whatnot. And the list goes on. So it stops around 130, and you could probably write a function to. The reason why I got up all the way to 130 was because I looked around, but you could definitely write a function to pull it out, which I did not do, but I leave that as a challenge to you guys. So I sorted it out. First off, I tabled it. TF 1.5 BQ